This is a computer UPS with a switching circuit and a transformer. If we give it 12 volts input, it gives out 220 volts. Now, after taking out the transformer, if we connect it in reverse, we can get an output of around 7 volts AC. Fine, but let's check the amperes because that is the sparky part. See? So here I have connected my clamp meter. Oh man, 40 amps. Yeah. Now, instead of a single transformer, I'm going to use 4 transformers together. I've also made these 2 metal connectors to connect the output of these transformers in parallel, and these connectors are from a discarded metal piece. One of the greatest reasons why I never throw away stuff. They can be useful anytime. To the first connector, I will be connecting the red wires. So all have been connected. Moving on to the blue ones. So here I am zip tying all the transformers together because it's the easier way to do it. Now let's connect the input wires in parallel, green to green and black to black. Green and black. Transformer is almost ready, and here I've used this old discarded mouse cable to make this big transformer handle because it is quite heavy now. So here I'm going to use these 2 yellow and black wires to connect them to the high voltage side, which are bundled together as green and black at the back of my transformer. For the output, I have these 200 amps wires from an old inverter battery. It is finally complete. Now here I'm going to use my series bulb to do the safety check first. So take one wire from the bulb and one from the transformer input and join them together. Now take the remaining 2 wires and connect them to your 220 volts home socket supply. Turning it on, the bulb is glowing dim, indicating that everything is fine. Anything else would indicate either improper connection or short circuit. So testing it with the same wire again, and this time the current is going to be very high. Extremely high current. 4 times. Whoa. Oh man. Oh, that was extremely dangerous. So you can see such a high current that we can get out from 4 transformers when connected in parallel together. So for the second experiment, I was thinking about using this. It is a spring and I have stretched it. So using it to heat this up and then in turn heat water with it. Let's dip it here. And here it is, rising quickly. 30 degrees. 40 degrees. 90 degrees. Oh my god. Yeah. We are reaching around 98 degrees. Let's turn it off. So now I'm going to use these 2 nails and try and weld them together. So it's on, and now I'm going to touch them. Oh. Oh. Wow. That is crazy. The current was so high that it could actually melt the tips and weld them together. After doing all these experiments, I got a little curious for finding out the maximum temperature that we can achieve through short circuiting this spoon. So here I have 2 vices that are holding the spoon. Next, I'm connecting this red wire to one end of the spoon. After that, we have to connect the sensor of the digital thermometer to the center of the spoon. Time to short circuit the wires. Wow. Oh man, the wire is not going to survive this. Just a quick touch. Oh man, it was 228 amps. So finally I have doubled up the wires to increase the current handling capability. Let's start the test. Oh, Oh, 270 amperes. The amperes are way too high because of the increased wire thickness. These wires, the transformer wires, cannot handle that much current. They will burn out. Now the spoon was taking a lot of current, so I had no other choice but to replace it with this spring. So let's measure the short circuit temperature. The temperature must be rising. Let me see how much the temperature is. 80 degrees. It's unable to measure beyond 100 degrees. Repeating the test with another multimeter of mine. Let's hope that this one at least gives me the proper maximum reading. Let's short circuit it from here. Whoa, that is so bright, man. It's melting. Oh. Now I have this long screw with a damaged head and I have this power window motor. So I thought about fusing the two of them together to elongate the shaft of the motor. Oh, scary. Off, 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 off. Whoa. Okay, careful. Oh, now we have a long shaft motor. So cool. It's all wobbly. But yes, it welded. So cool. Now I have the silicon steel from a transformer and I was thinking about finding out the drawn current. Oh, oh, how much is it? Oh my god! Shit, man. Oh, crap. And go. Oh, oh man. Oh, that is so bright. Oh, that is so cool. It was so stupid of me since I forgot to switch it from DC to AC mode since I have not connected any rectifier. So now I'm going to use this silicon steel. It is from another transformer, different kind. Go. Oh. Whoa. How many amps is it? It looks so cool and very hot, man. Whoa. It is red hot. That is so cool. Oh my god. Oh, it's not coming out. So how many amps was it? So let's check. Now you can further increase the amperes by adding more such transformers in parallel depending upon your requirement. Now there is this curious thing to note. While the transformer was on, the maximum water temperature was only 98 degrees. But as soon as I turned it off, it went to as high as 99.8 degrees, which is close to 100 degrees. Why is that? Let me know in the comment section. So these what you see are some propellers, 11 inches, 12 inches and 14 inches. In my previous video, I made this 15,000 RPM DC motor using some gears. And in that video, I told you that I was going to test to find out which propeller is going to make it fly. So here I have different sizes and I'm going to try that now. So first I'm going to connect this 11 inches propeller. So everything has been connected and here I'm using this 24 volts 20 amps power supply and go. Now here I have this controller with which I'm going to control the speed of the propeller. So the lift was better than before, but still it could not fly. So here I'm going to switch it with this 12 inches propeller. So even the 12 inches propeller is unable to lift it at full power. So here I have finally connected the 14 inches propeller. It is time to turn it on and go. As you saw that none of the propellers could produce enough thrust to lift up the motor because of the added weight. So that's all for today's experiments. I hope you enjoyed them. See you in the next one. Stay creative. Bye bye.